functions. Luckily, I just in the first slide only. Okay, so modular programming is actually, you can understand in this way. You actually break into a smaller module. Okay, each of these functions you just break into a different module. So that's why we call it as the program that actually break into a small independent or module or functions. Okay. So each module performs separate tasks with a single purpose. So when we break into different module, so each of these modules is actually holding a task. Okay. Let's say task A. Okay. Let's say I have a big program. I have a big task. I actually break into modules. Okay. I have A module, B, C, D modules. So each of these modules actually performing a single task. Okay. It's actually holding a main task. Okay. To maybe to process a specific actions. Okay. So that's what we call modular programming. Okay. So next we have this structural programming. Is actually similar to modular programming. So it's actually break a big problem or a large problem into a smaller sub problem, just like actually breaking into different small module or related sub module. Okay. So structural programming, maybe you can just imagine that in your code, you don't write everything into your main program. I believe that inside your this practical exercise, so when you're actually working on the exercise, each of these questions, you start from the main method and then you put everything into the main method, right? So now you actually break into different functions, so you make it more structured and more easier to manage. Okay. So let's take an examples here. So you wish to build a program that simulates ATM. So what are the main modules that we have actually inside an ATM? I believe you all been to the ATM and actually take some money out and do other things else. Okay. So what are the main modules inside? When you look at the screen, you put in your debit card or credit card inside debit card. Okay. You put inside. So on the screen there, what it show you? No money. So you will be you got a lot of money lah. Okay, so money. You have functions, okay, or you have a module to check the balance inquiry, right? So other than balance inquiry, to check your balance, your account balance, and what else you can do inside the ATM? What? No more. You can deposit money. You can withdraw money, right? And what else? You can actually do what? Payment. Let's say your electricity bill, your utility bills, you actually can pay through the ATM. Okay? And maybe you transfer money to another bank, or you transfer money to your friends. Okay, you have what? You have a transfer functions, we call, right? Transfer transactions. And what else? Maybe you want to change your PIN number. You can actually do it in your in the ATM with your ATM cards insert into the machine, right? So let's look at this one. So these are the things that you actually have when you actually go into the ATM, and then you have this all this module. Okay, we call it. You can see that we have cash withdrawal, payment, transfer, instant cash withdrawal, balance inquiry, PIN change, account selections, or other services. So you can see that in this program here, in this ATM program, it actually break into different module. Okay. Let's say cash withdrawal is actually one module, payment is actually one module, transfer is actually one module. So you can see there's actually a few modules here, means that we actually break into different function. When withdrawal, then only we have these withdrawal functions. Okay, so when you click on this payment, maybe you have a bill functions or a payment functions to pay your bill, right? So let's say transfer. So you actually have a functions to transfer to money from one account to another account. So inside the transfer, you actually cannot withdraw money because you only focus on one main task, which is actually transfer your payment, okay, to another bank or something. Okay, let's say in your balance inquiry, I actually break into one module one function. So when I click on this, I only can check the balance, the account balance. You cannot do cash withdrawal in your balance inquiry. So we actually break into a very small module, okay, based on each of these functions, right? So that's how we use this modular programming to design, and also structured programming to actually code to come up with this kind of program. All right. So why we use functions? We use functions because it's actually easy to manage. Imagine that if you have different functions compared to you only have one function, let's say your main method in your code. So everything you write inside there, it will be very messy if everything in one function. Okay. So let's say you have we say manageable code because when there's something wrong, let's say the cash withdrawal function is wrong, maybe I just check on this module, this function, right? I don't touch with any other module. Let's say if today I did not use functions, everything I develop an ATM program in one function, one main method. So when I change something, it might be affect other functions, right? Because everything is actually run in one function only. So that's why we need separate functions to manage our code. And reusable code enable the same code to be reused. Okay, means that maybe the functions can be reused for other person, for other peoples, okay, for others sections, alright. And to protect data, so we can make the related data available only if they are needed. Let's say my balance inquiry, I only show my balance, okay, in this function. So in this function, so I don't see my PIN, right? So I actually protect the data based on the function and based on the module. So when I click on this balance inquiry, I don't see PIN number, something. Okay, so we actually protect data based on the use and the needs. Okay, let's say withdrawal amount is not related to the deposit amount, then they should be not lumped together. So when you withdraw, then you see your balance. When you deposit, you only see how much you actually deposit inside. Okay, you don't see any other information. And of course, it's actually easy to debug when you have multiple functions. When something wrong, you can just focus on this part. You don't have to focus on the whole thing, right? So we say that it's easier to find your errors, okay, and focus into and work on the module easily, which contain this error. Okay, so in functions, it only contribute to only one main task. Okay, consists of single entry and single exit, and use meaningful name for the module. So the first one, contribute to only one main task. Like I just said just now, we take this as an example. So one main task. So this function is only for withdrawal. Then you do nothing other than withdrawal. Okay, so it only contain one main task. And single entry and single exit. So means that once you finish your withdrawal, then everything finished. If you want to check balance, then you have to go to another functions to check balance. Alright. So that's why we said it consists of single entry and single exit, and use a meaningful name for the module. Of course, every functions you have to give a meaningful name so that you actually understand what is this function doing, and other people when they maintain your code, they actually understand what you're actually doing, what are the functions doing. So meaningful names or meaningful functions is very important. And a functions may or may not return a value. Okay, this one we're going to expand and discuss further in the upcoming slides now. Okay, so return a value. So you can use a structure chart to show the hierarchical relationship among this module, just like this one. Okay, this structure chart, you can see that we actually have a big program, and then we break into different tasks or different module or functions. Okay, so this is examples here. So this is a program. Okay, this is a C++ program. So what is this program doing? Maybe you have a look here, and then you can tell me what is the goal of this program. What is this program achieve? I actually I let the user to, I prompt the user to enter the phone number. Then I prompt the user to enter the call usage. So what is the goal for this program? Why I create this program? If you look at this sample, to generate bills, right? To generate bill, because you can see after I enter this phone number and enter this call usage, then below here I actually generating the phone bill summary. Okay, so basically the goal for this program is actually to generate bills, generate phone bills. Okay, so if you look at this program below here, once I enter the phone number, so I generate the phone bill summary, I actually display the phone number, and I display the username here. Okay, so did I prompt the user to enter the username? No, right? So I'm actually, how do I get this username? I actually use the phone number to search for the username. So this is actually considered one functions. We call it search functions. We're actually searching the username based on the phone number that entered by the user. Okay, and then next is actually to do a calculations. Okay, I actually retrieve the summary, the call usage from October 1st of October to 31st October, and then my call, my billing, and also my total. So in this part is actually my calculation part. So calculation part is actually considered as what? As one function. Okay. Okay. So this function is actually focused to focus to do the process, to do the calculation, to generate the total for you for the program. And then lastly, I actually have a functions to display the message and tell the users that this is the deadline, the due date for the payment. Okay. So suggest how would you modularize the program above? So how do you split into different functions by looking at the output of the program? So first thing, for this enter phone number as enter call usage, so this part is actually one function. What is this function doing? Huh? From the user. From the user means what? You're actually getting data from the user, right? You're getting information or getting data from the user. So that's why you ask user to input. So this is one module. And you actually can break this header. You can see this one dotted line here, the phone bill summary. This is actually the title. So this is what we call it as the header. So you can use the functions to generate the header. Okay, the header. And then okay, this one just like I already mentioned. When I have a phone numbers, if I want to get the username, I actually have a search function. So the search function is actually considered a module or consider a functions to search. Alright. And then next is your calculation function and to display the due date functions. So if you look at this, structure chart here, so you can see that the main goal of the program is actually to generate bill. Okay, but to generate a bill, what you need to do is you have to call to the user to read the user data once the user input the phone number and the call usage. Then after that, you're going to call the print bill. So under this print bill, I actually break into 4 different modules here. So first thing, I'm going to print the header. So this is the header. Okay, this is the header. And then the next module I actually use to search the username. So search the username based on the phone number. So this is one function. This is one function. And calculate phone bill, the calculation process. So this is also one function here. And lastly, I actually print the due date, or we call print the deadline, right? The deadline message here. So this is the last one. Okay. So we print bills and we actually break into different smaller modules, okay, to focus on each task. So you can see that this is actually what is the main task for this one? To print header. What is the main task? Just to search the username. So this is one module. So this one, the main task is actually to calculate only. Okay, other than calculate, you will do nothing. Okay, you will not search the name. So when you want to search the name, you have to go to the search functions. Alright, and then lastly, print deadline. Okay. Okay, so in C++, there's a standards. Okay, how do you write your functions? So this is the practice. Okay, the procedures that you use to create the functions in C++. There's three elements here. One is your declarations, and one is call, and another one, the last one will be definitions. So the first thing is, when you want to create the functions, you have to declare. Just same as when you want to create a variable, you have to declare first, right? int, then variable name, right? So in functions, also the same things. You have to declare. Okay, let's say void headers. Okay, I'm going to declare that I'm going to create these header functions. So header functions is actually your function name together with your these braces, this bracket here, these braces. Okay, so these form functions, and this is your return type. We're going to explain this in the slides. And next is the call functions here. So in my main method, this is my main method. Inside every C++, you always have a main method to execute the program. Okay, so this main method here, I actually put in my header functions because I want these programs. Okay, when I run this program, I actually call to this header function. So when I call to this header functions, it will go to where? It will actually go to your definition, your functions definitions. Okay, so here is actually where you actually put all your statements, all your actions, okay, in these functions here, right? We call it as functions definition. Okay, this is functions declaration, function call, and functions definitions. Alright. So let's take a look on the first one. We call it as functions declarations, or you can call it as a prototype, or functions prototype also can. Alright. So the general format for a prototype, there's 4 elements here. You have to remember, first thing is actually your return type. Next is your function name. Next will be your argument type. ARG stands for argument. Argument type and your argument. Argument means your value. Argument type means your data type. Okay. So return type, what value the functions will return, and the function name is actually what the functions will be called, and argument type is actually the value, and also the data types. Okay. So this is the examples. Let's say my return type is actually a double. We're going to learn about return also. Okay, what's the return statement, or what is the return type, and this is your functions. So as I already mentioned, that when you're creating a functions, you should use a meaningful function name so that other people that maintain the code, they understand what you're actually doing. Okay, and this is your argument type. So like I say, argument type is actually your data type. Okay, it can be integer, double, string, float, any of this data type. Okay, so and also you have your arguments. Your x and y is actually your arguments, right? So if you want to declare in this way, also can. But if you want to create in this way, also can, without the arguments. Just put in the argument type. Both of these functions are correct. Okay, are correct. So once you have declared your these declarations here, your functions prototype, then you will go to this function definition. So this is where you actually contain the code to complete the task. So every process will be in these function definitions here. Okay. So it's actually made up of functions header and the body. So this is the header. So it may or may not receive some data through its argument list or parameters. So in this argument list is actually what we're actually talking about here, the argument type and the arguments. Okay, you can call it as arguments, or you can call it as parameters. The parameters. Okay, usually I use parameters. Okay, but it's easier to understand. And then we have functions body. So this body used to perform specific actions for the functions means that once you create a function, okay, what are the things that you want to do? You actually do inside this function. Let's say I have a functions. I actually have an actions called a plus b. So this is an operation, right? So a plus b will be placed inside this function's body to perform the actions. Okay, let's say like example. Then we have a return statement. So this return statement, it may or it may not return the function's value to the calling module or functions. We're going to see a samples about how everything works and how is this return statement works. Okay. Okay, before I go to the next one, I'm going to show you the sample. I'm going to use the online compiler. So I'm going to use okay, you have your include directive, you have your using namespace, and also your main method here, okay, in your C++. So let's say today I want to have I have add operation, additional operations. Means I'm going to add a plus b. Okay, I'm going to use the functions. Okay, I'm going to call a functions to do this, to perform these actions. So the first thing. So what is the first thing I need to do? I want to create functions, right? So I'm going to follow these steps here. First thing, I'm going to have this functions declaration. I'm going to declare my function first. So I'm going to have a int add. Okay, and then inside. So we're adding a value. You need how many value? Minimum. You minimum have 2 lah, right? A plus b ma. How? If not, how you actually add, right? So my variables will be integer, okay? A, and then next is actually integer b. Okay. So after I done this functions declaration, then I'm going to create my functions. So same int add functions. So now I actually have an add functions. This is my function name. So here, same. I have this int a and int b. So this is my parameters. Okay, my parameters. So inside these add functions, I will have a return a plus b, which is my operations here. A plus b. Okay, the next one, what I need. I have declarations, I have definitions. Then the next one is actually you're going to call the functions. Now you already have the functions ready, but your main method have to call it out. Okay. So I'm going to maybe to show the final result. Let's say a plus b is equal to how much? So I'm going to pass a value inside, right? I have to pass a value for a, and also I have to pass a value for b. Then only I can do the operations, right? Okay, so I have a C out here. I want to output. Then I'm going to call the functions. So the first parameters I put 3, and the second parameters I put 4. Okay. So now I have my output here. This is my output. We say call functions. So when I run this program, the program will go and the first thing you actually go to this main functions here. So if you execute, then you actually have output here, and then you actually call to the function. That's what we call functional call. Okay. So once I have this add function here, and then I actually have my parameters, right? 3 and 4. This is my value. So this value, these two value, will be passed to where? We will actually pass into the functions here, because you call to the function, you actually telling the functions, hey, this 3 is actually A, and I'm passing you 3 and 4. 4 is B, 3 is A. So it's actually followed by the sequence. Okay. So the first one will be actually pass into the first variables here, and the second one will be into the second variables. So once I have these 3 and 4, I have my operation, right? So 3 plus 4 equals to 7. So once I got this, let's say the answer here is actually 7. So is my output become 7? And what is this return doing? Yes, okay, return the value back to where it's actually being called. Okay, so let's say I call, call this add functions, okay, and then I call this. Then I perform the operation. So this is actually, the A plus B is actually my body, okay. So once I perform this action already, then I got the value 7. So this 7, I'm going to return. I'm going to return to where this add function is being called, which means here. Okay, it will return to here. So here, the result will be 7. So this Cout is actually the output, right? So I actually expect my output is 7. Okay, so if I run this, and you can see that the output is 7. Okay, so means that these functions here is actually returning a value. Returning a value to where it's actually being called, which is here in the main method. Then lastly, I output, so that in the output here I can see the final result 7. Okay. Okay. Let's go back to our slide here. Okay, so if you look at these functions definitions here, we actually have two types of functions. One is the void function. One is a value returning functions. Okay, so just now the one that I demonstrate to you is actually a value returning functions. Okay, return a value, it will return a value. So you can see that it will return the function's value to the calling module or functions. So we always use return statement. So remember, when it is a value returning functions, you always need a return statement. Okay, return the function's value to the calling module or function. So return back the value to the calling functions here. It will always return. Okay. Okay, what is void function? Does not return a function value. So it actually can receive value from the calling functions only. It can receive. It will not return. Okay, it will receive, not return. So how do we do this? Let's say now I need the functions to display a message. Okay, I display a message. So I'm going to declare my functions called void show message. Okay. So yeah, below here I'm going to create a function called show message. Is it able to see? Is it small? Okay. Okay, in here, I'm not doing any operations, okay, add, subtract, no. I just want to output a message. Maybe I'll put it as end of program. How come? Okay, let me know if you cannot see. I think because I want to see the overall here. Okay, so now I actually have a void message. I created the function definitions. This is the functions because the functions definitions. Okay, I have declarations, I have definitions, and lastly, I need to have a functional call. So after I call these add functions, I want to output this message. So I'm going to call this show message. Do I need to put any parameters inside? Do I need to put any parameter inside? No need, ma. Because when I declare, I do not put any arguments inside. So you don't have to put any value. Okay. So let's see. Do we have these two lines? One is 7s, and after 7s, I will expect to have this end of program message showing below the 7. Why is it at the in the same line? Because you do not have a end line. Okay. And now you can see that you actually have two lines here. Okay, so what is the difference here is, okay, we talk about these void functions. So when you're actually declaring a void functions, you don't expect any return value. If you look at these functions here, do I consist a return statement? No. It actually call for one time only. For this add here, for this add functions here, I actually have a return. So that's the difference. Okay, if you just want to display a one-time message, okay, there's no operations inside the functions, you can actually consider using the void functions to display the message. Okay. So there's two functions that you need to remember. This is a very common thing. Okay, you need to remember in creating a functions. You have to choose whether a value returning functions or a void functions. So just now I already show you a real demonstration here. So below is actually the sample. Okay, I already explained. Right? Your functions prototypes, okay, you declare, and then your function call, and this is actually your functions definitions here. And when it's void return type, then there will be no return statement. Okay. And value returning, same thing. So you have functions declarations and functions call, and these arguments, or call it parameters, and you always expect a return. So this int here, I already said that it can be any return type, not just int only. Okay, this is just an example. Sometimes maybe you can have a double data types. Okay, you want to return a double value, or you want to have a float value. Then you just put lah. This is your return type. Okay. Okay, next one is the parameters passing. So we're going to learn pass by value. One of the parameter passing method, just now I already show you lah, pass by value. When I call this function, I actually pass the value to the functions. Okay, so this is what we call parameter passing. So a copy of data is actually created and placed in the local variables in the call functions. And the original data in the calling functions are saved and remain unchanged. So we have a look on these passing techniques. Okay, this is actually a preferred passing techniques because it actually protect the data. So if you look at these functions examples here, Okay, so I have a C++ program here, and you can see that I actually have a declarations of in an integer a equals to 5, means that this 5 is actually what? It's actually assigned to the variable at the left side, a here, the a value. So I'm actually calling this fun function, and this fun function is actually a void. So I'm passing a, right? Means I'm actually passing this 5 inside the fun function. So when I'm passing this parameter, this value, I pass to the fun function, I actually have a parameter here to receive the value. So the 5 will be going to the x here. So this will be 5. The value will be 5. So x equals to x plus 3. So you actually perform the operation. But then this is actually a void. You don't return the value. So the value will always stay in this function. It will not return back to the main function because it's actually a void. You don't return anything. So it's actually a copy only. So when I actually call this one becomes 5. If I see out this a here, there will be nothing changed because it's not affected by the function fun, right? Because it doesn't return anything here. Okay. Okay, function call I also already demonstrated just now. Call functions by using a function name with the braces and list the parameters inside the brackets. If it define, let's say additions, you have these functions here and it accept x and y. So means passing x and y into the functions to do addition. And then you have empty parameters here. Means that you only just to display the value. You don't put in any value. Alright. Next, passing mark into the functions and store the return grade value. So examples, you actually have a find grade functions and then you process already, you get the final result, you're going to store into the grade here. So I hope you understand this one. It's just like I'm adding this. So assigning variables into, to store the grade value is just same as this one. Okay. Let's say examples, I actually call to these functions and I want to store to a new variable. So in your main method, you can actually create a variable, maybe called result equals to add 3 and 4. So once I return the value, I actually put it into the variable called result, right? So in here, you actually output the result. Same. The output will be the same. Okay. Just that one is actually directly output the value. This one is actually output already. You actually store into result first, the result variable, then only you output. So 2 ways here. And examples, print the value returned by the functions directly rather than assigned to a variable. Yeah, this is what I actually doing just now. This one. Okay. So you can actually use in this if statement, switch or your while loop or your switch case here. Okay, to check the value returned by the functions. So you actually can use the functions to do condition checking. Okay. Like this, calculate, okay, the functions that return have to be less than, the value that returned from the functions have to be less than 100, or to see whether the case is it match the return value here. Okay, so this is function call. We call functional call or function call. Okay, so this is the examples. We have these functions prototypes, main, the calling functions, and the functions definition. So always remember, in user-defined functions, there's three things here: functions prototype, function declarations or calling functions, function call, and the functions definitions here. Okay. Yeah, this is another examples. Okay, I want to show you one thing. Okay, just now we actually follow the practice, right? What the slide actually showing. We actually have three things that you need to follow, which is your declaration, your call, and your definitions. So now I'm going to show you another way that you actually can combine these declarations and these definitions together. Okay. So if I want to combine these declarations and definition together, I can just remove this functions declaration. I'll just comment it out first lah, alright? And now I actually have the show message definitions and the add functions here. So I'm going to move this. I move this on top of the main method. On top of the main method. Okay, and then if I run this, I will get the same output. Alright, and you can see that I actually get the same result here. So you actually can combine. Okay, you just combine your declarations and your definitions together, or if you want to follow the slides, how the slide show you declaration, call, and definitions. Okay. That's also okay. Okay, there's two ways. So in this way, you actually skip one step lah. Okay, because when the program run, you will find these to declare the show message and the add functions together. Then you always go to the main methods to execute the first line of code here. Okay, so yeah. So there's two way here, and let's continue. So yeah, next one is the flowchart. So let's say the question give you this sample of code, okay, and then you actually have a few functions here, and ask you to design a flowchart. So the first thing you need to do is actually you understand the program based on the sample functions code given in the question. So let's say I have a main method. So what's the first thing? Because every time you run the execute the program, you always start from the main method. Okay. So first thing, you actually declare your sum, your A and your B variable into an integer data types. And then next you actually call to the title. So after you call to the title, you actually come up with this welcome to addition message. And then you actually output this enter to integer. This is the flow. So after you enter already, you actually performing the additional functions, the add functions. And lastly, you output the result message. So if you look at this flowchart here, so you always have a start and end. And the first thing you do is actually you declare and also you call the first function here. So the process here, you actually have a title call, a function call. After function call, you actually have to prompt the user to enter. You have to prompt and read lah. This is the input output function symbol, right? To enter these two integers and the output and input. And then next you're going to do a process, right? A specific actions, which is addition. So actually you have a process to actually count this sum is actually equals to addition A and B, which is your parameters here, your value, right? So these additions we actually call to the addition functions to do this A plus B operation. Then you return back. So once I return back, I display the output. So this is to display the sum. Then lastly, end the program. So this is a overall flowchart, okay, based on the functions code given. Here you design a flowchart. Okay, these two flowchart is actually mainly focused on each of these functions that you have inside your program. First is your title functions, and next is your addition function. So the title is actually to display the message only, so you can just start from the titles, okay, and actually return nothing lah, okay. So for addition functions, okay, you actually perform these additions, and then you actually process this sum equals to A plus B, and then you return the sum value. Okay, so this is just a flowchart for you to see. Okay, how do you actually design your flowcharts when you actually have a based on these functions here. Okay, so there's some questions here. So if look at this code, fill in the blanks. Okay, actually given you the output already. So what is the first field here that you need to fill in? What is the first thing? What you need to fill in here? Don't know. Very hard. Very difficult. The first thing here is actually your functional declaration or your functional prototype. Okay. So when you look at this output, you need to understand and you need to identify when you look at the output. The output here is actually a what data type is this? This is a double data type, right? Because you actually have a floating point at the back there. So I assume that this is actually a double type. So what I need here is actually what? Maybe you just write down. Okay, so in first fill in the blank, this one will be my return type is what? Double. What is my function name? Multiply. And how many parameters inside? 1 or 2? If you look at this, you're actually calling the function, right? So 3.2 is what? Your argument type is what data type? It should be double, and maybe you can put A lah, put X also can. This is just to declare only. Alright. So the second one, the second field that you need to fill in, if you look into the right side here. So what is this? What you have to put in? Right. Now you're actually creating the functions definitions. So double, same lah, multiply. Then what is this? The data type, your argument type. Same lah, double lah. Right, double y, double num. This is number 3, this is number 3. So 4 also, what's this? Double, same. This is also double, okay? Yeah, this is a double type. So double answer, this is your variable lah, your double variable equals to 2 times your double variable here, num. So this num, where is this value come from? From here, right? From where you actually call the function. So you're actually passing the value, the parameters into the multiply functions here. Okay? So, yep. And next one, okay, this one I'll just let you to do it. Okay, same thing. You just put in what you need, fill in the blank, 1, 2, 3, 4. This is actually a string, I'll just give you a hint. Okay, So same thing, so we have a lot of questions here. So I already finished one, and you go and try this one. If you want to test whether the data types or the answer that you put is it correct or not, you can always go to the online compiler. Okay, go to compilers and put in all the code inside to see whether you can get the output or not. Okay, test on this online compiler faster and easier. Okay, so we go to the next one. Okay, redesign the code below by using modularizations and produce the structural chart. So the first thing we do, we take a look here. How to split into different module. How to split into different function. You can see that now everything is actually running in one function, in one main method functions. So now I want to break into different module. Is it very hard to do it? You just have to know so the first one is what? The first one, can you tell me the module that I can actually break out? Get input. Yeah, get input is actually a function, right? Get input is a function. So after I get the input already, what I do? Then I actually have what? Calculation. So I actually have a calculation function. So now I have two already. First function is to get the user input, and then the second function is to calculate. Then the last function is what? I'm going to split it into three. To display the total, right? This one is actually to display the total message here. Okay. Maybe you just try it out in these online compilers here. Okay, first thing, what I need. Okay, if you look at this, I actually have this. First thing you have to understand how is this program works. Okay, so first thing I actually declare this x1, x2, and x3 and the total. So I have total of 4 variables. Okay, I actually declare 4 new variables under the integer data types, and then I actually have a do while here. So in this do while, I actually prompt the user to enter 3 positive number. Okay, so I have an input here to check to receive the input and put into x1, x2, and x3. So this do while, okay, I'm going to do first, then only I do the check-in. Is x1 greater than 0? No, sorry, is 0, is it greater than this value here, x1, x2, x3. So we do this looping here to do checking. Then I have this calculation, means to add up only x1 plus x2 plus x3. Then I display. So I'm going to use the way, okay, the three steps, okay, declaration, function call, and function definitions. Okay. So this is actually to show the total only. So I'm going to use something called a global variables. Later I'm going to explain what is global variables. So int, I have this x1, x2, x3, and lastly I have a total. So inside my function declaration, just now I said already I have 3 different functions. Okay, so void Get input function, is it a void? Only receive only one, right? I don't return. Get input. Okay. And my calculate total. Is it a void? I actually have this I have these variables here already. So these global variables maybe I'll just give you some heads up here. The global variable can be used in every of these functions that I actually create later. Okay, so you actually don't have to put in pass in the value into these functions. So I just put void first. Calculate. So I have three. So these three also I use void functions. Okay, I don't use value return functions. And inside my functions definitions here below, I have this void input get input. So I'm gonna put what? I'm gonna put this do while inside now, because this is actually prompt the user to what, enter the three positive number. Okay. So I just copy this and paste here. Then I just adjust to make it nicer. Okay, so where's my bracket? Okay, I have my get input here. So enter this one will be okay, enter three positive numbers and I have a while loop here. So after this, I have another functions called void calculate total. So this calculate total will be total equals to x1 plus x2 plus x3. Okay. So after that we have this void display total. So this display total will be have a cout functions here called okay, so now I have three functions here: get input, get calculate total, and lastly I have a display total. So inside my main method here, the first thing I need to call is get input. Just copy it. It's very hard to type. Copy and paste. And next one, calculate total. Lastly, display the total. Okay, so I'll try to run this program. So if I put 1, 2, and 3, so the total should be 6. Okay, the expected total should be 6. So I press enter. So you can see that the total is 6 because it actually totally you total up this x1 plus x2 plus x3. Okay. Okay, in this sample only actually using these global variables. So wait, let me show you the different. Okay, let's understand a bit on the variable scope here. we have two variables type here. We have one called local variable and another one called global variable. So local variable means that we actually declare within the function body and not accessible by other functions. And global variables declare outside of any functions in the program and accessible to all functions within the program. So the one that we're actually using just now is actually what we call the global variable. Okay. So when I declare the global variable, in the main, I can get the value. It can be accessed by any of these functions here. So in the get input, when I call to this x1, x2, x3, I can actually retrieve this value. Okay. And yeah, your calculator total, your display total. So if everything outside, we call it as global variable if you declare outside. Okay. So how do you, what does it mean that local variable? Declare within the function body means that in every single functions here, you have your own this variable declaration. We call it as local variable. So let's say if I put this, copy this, if I put it into one functions here, if I put it here, let's say I don't have this one. So if I create this one is a local. This is what we call a local variable. If you declare your value in these functions here, means only these functions can access all the value. Okay? If you want to get the value from other functions here, okay, let's say in this function, this get input functions, if you want to get this x1, x2 and x3, you cannot access. Okay, this is only run in the local functions here, the local variable. Okay. So if I want to use, let's say, if I want to use this, let's say, I declare already this value here. So if I want to get this value, how to do it? How to declare? Let's say the value here. Let's say the value like example. The value x1 is actually equals to 90. X2 is equals to 50 or 60. So in order to get this value, I have to pass it into my function first. Then only you can get it. So let's say the get input here, I need to declare, let's say my INTA, INTB, let's say these two lah. So my get input, when I declare, I need to have this INTA and INTB. So when I call this get input, I need to pass my parameter x1 and x2 like this. Okay. So in this way, let's say in these functions, I actually have a variable called x1 and x2 which contain the value of 90 and 60. If you want to share to other function, you need to actually receive it. Okay, the parameter. So when you call this get input, you have to pass the value. That's what we call passing the parameter value, okay, into the get input to receive. So when I put x1 and x2, so this value 90 and 60 will be passed into the A and B, and then you can be used in these functions inside. Okay, this is how you actually use local variable. But then in these examples, I just use global variables because I just want to show the total only. Okay. Okay, let's say one more thing. Because this value is actually running in these functions only, right? Let's say this 90. So if I pass this 90 into get input, then I receive 90 here, right? So let's say I receive this 90. If I modify, I want this A equals to 900. Okay. May I know will it affect this 90 value? Let's say okay, this A here, let's say I actually call it to this get input, right? Then I actually passing this x1 and x2. So this x1 is actually 90 and this x2 is actually 60. So I pass it to this get input. So I will get this what? This value will be 90 and this one will be 60. So okay, so now I actually doing something in this function here. Okay, I get this value